Hey there, welcome back to Coding at Home with the Code Hub. Hey there, welcome back. We are in day 3 of building our own app. Originally, this was kind of designed to be a Swift Student Challenge inspiration session. Of course, we missed the deadline for that. That was Sunday that just went by. But this is great fodder for your app for next year's Swift Student Challenge. And you kind of need a bit of time to work on it as well. So hopefully by the end of these 3 days, you'll have had a bit of time to think about what it is you want to build, and we'll have given you some tips and tricks for how to build it with some of these playground templates that we have lying around, either from Apple, from us at the Code Hub, or from elsewhere. There's some great playgrounds from Italian schools and Spanish schools. Some of these teachers have put out amazing playgrounds. There's an excellent teacher in Australia who puts out some great content. I'll have a link to those in the video description for today. And you can go add those to your own playground and play around with some of the stuff that they've designed for you. Swift Playgrounds is all about exploring and kind of playing around with coding and trying to start your programming journey and continue it. So they're all ideal playgrounds for that kind of thing. I want to plug the look back session again on Friday. We'll be doing it again 1 p.m. Irish time. It's a Zoom call, so make sure you register. I know you can't see half the URL. Again, I'll post the link in the video for today. Sign up. It's a pretty low-key, low-volume type of interaction. There are not many students on, so you get a lot of time to ask questions and take things in a direction that maybe you didn't know you were going to go in, or that you really did want to go in and that I wasn't going in that direction. So so that's my plug for the look back sessions. I highly recommend signing up. Today's probably going to be our last time playing around with the app playground. We've had a ton of fun. We could spend forever and a day going on through different scenarios and adding new features and building an actual game. Maybe we'll come back to that and do it again after we're done with some of these other playgrounds, because I want to get to augmented reality for you. I want to get to finish off the camera, assemble your camera playground, and then get into actual building of iPhone apps with Xcode and stuff like that too, for the more advanced coders amongst us. But for today, we're going back to building our app. So let's go over to the device. All right, so here we go. We've got our app at home playground that we've been playing along with. Again, if you're just joining us today and you missed the last 2 days sessions, you just go to see all down here. You scroll down to the Code Hub Swift Playgrounds feed if you have it installed. And it'll be that second playground. So app at home, just hit the get button and we'll download that. So we'll open up our own app at home that we already have downloaded. So I have my space, I have my left button, my fish one, the treasure, right, which was an image view that we would add to this whole scene. Our fish two, which is another button. And we use that at the very end of yesterday's session. If we go down to the bottom, way down to the bottom, we wrote this press whale function. Because remember, we gave the fish 2 a whale image. And we accepted a parameter called pulse, which is of type pulse. And we had this little state variable here saying if is ballooned is false. So if I came in here and I would say, oh, if is ballooned, well, it's false, so I'm not going to do this. I'm going to fall into the else clause. I'm going to set the fish 2 scale to 6, and then I'm going to set is ballooned to true. If I come through again and this is set to true, then we'll say, oh, yep, we are ballooned. So we're going to set the fish scale to 1 and then set is ballooned to false. Very important that we flip that Boolean variable back to the other value. Now, the other way we could have done this and save ourselves some lines, because what we'll be talking a little bit about today is refactoring that we mentioned in chapter 10 of Everyone Can Code Puzzles, where we look at the code that we've written and we say, do you know what? There's a better way to do that. Or I can do it in less lines and it'll save me a bit of time. It'll save Swift a bit of time. So let's try fixing that. But first, we see that this is how we get it called. We say fish2 press property is connected to this press whale function. That's how we've got it wired up. All right, so one thing we could do is we notice that we're just toggling this to, in this case, is ballooned is true. So we're setting it to the opposite value. Do you remember when we talked about logical operators, what logical operator we could use to always flip this Boolean variable? Well, what we could do is let's select this guy as text. We are going to cut it, which will delete it from that area. And we're going to put it down below here. We're also going to cut this one because we don't want to set this twice. We're going to try to be a little bit more efficient. So now when I'm in here, I just check to see if is ballooned is true. If it is, I'm going to set the fish scale to 1. If it isn't ballooned, then I'm going to set the fish scale to 6. Now my way to toggle this, well, let's try running it first. Now, can you guess what's going to happen here? If I hit my left key, remember this happens when I press on fish 2. So I'm going to press fish 2. All right, so he's gotten very big. And I'm stuck very big because I never set is balloon to true. So the way I could have fixed that was if I tap on false, I could say, well, I want to set it to the opposite of what is ballooned is right now. So I can use the not operator. And I want to change is ballooned. So now if I run my code, remember I've taken out those 2 lines of code and I've replaced it with just 1. Now he's big. Now he's small again. Big, small. We could do this all day. In fact, for the rest of the half hour, that's all we're going to do is tap on the whale button. So I've saved myself 1 line of code, which isn't huge, but it's not bad, by just using my knowledge of the not operator to flip my is ballooned variable in my press whale function. Okay, cool. So that's one thing we could do, one little bit of refactoring. The other places you might refactor is when I look at my move left function, it's actually gotten kind of big. Right, so I have my fish1 actions in there where I say, okay, well, if the fish's X position is less than -50. So if it gets over on this side of -50, we're going to scale up the fish. And then we're going to create this random X position, random Y position. And we're going to add a treasure at that random point with a medium size. Well, this whole bit here, we might want to pull out into another function called maybe add random treasure. Will we do that? Let's create a new function here. So we're going to tap on the func autocomplete button. We're going to call it add random treasure. And in the function body, we're going to go take, actually what we'll do is we'll say, let's take everything from here. We're going to select everything from here down to here. This is all my code that creates a random position and then adds my treasure at that position. So let's do that. Let's copy that. Actually, let's tell you what, let's cut that, which will delete the code and then add it to my pasteboard. And then I'll paste it in here. Okay, cool. Now I'm not super keen about this function because I don't have, I'm assuming that I have a treasure component defined somewhere else. I could actually add all of that stuff and basically encapsulate all of my treasure functionality inside that one function. So let's do this. Let's take this line here and we're going to cut it. And we're going to add our treasure to our add random treasure. So now I can't access treasure outside of there. It's only inside this function. And then I'm going to take the treasure image. I can't, it's showing me an error because that doesn't exist outside of my function anymore. I'm going to cut that. I'm going to set my image for my treasure here. If I run my code now, what's going to happen though? Am I going to get my treasure back? Well, no, because I'm not adding random treasure. So let's call that function. This is a little bit like you might, say, oh yeah, this reminds me of the Everyone Can Code Puzzles playgrounds. This is very like move forward and turn left. I'm calling functions from within other functions. So let's hit left and get the fish on the other side of -50. Okay, there's my treasure. Ooh, this is actually even better because now I don't have just one treasure that I'm adding to the space at a certain point. I've actually got multiple treasures. That's very cool. I like that. So that may be a better way for us to create the treasure. Now we could have done that in line here, but by creating our own function, we sort of say, all right, look, all this stuff is related. All this is related to creating a treasure, giving it an image, finding out a random position for it, and then placing it on the space. If we only ever wanted to have one treasure and have it move around like we had before, well, then we would drag that treasure out of there and put it back up where we had it, up here with the other components. When we create the components, we'd put our treasure up there. Okay, cool. So that's my fish and my whale. That's a little bit of refactoring. I pulled out random treasure so that I've got a whole chunk of code. If I ever want to work on the random treasure stuff, I know that this is the function that I'm working within, and I don't have to dig through the whole move left function. Okay, so this here, what we do is we have another bit of code inside move left where we basically check to see that, hey, so long as we're greater than -450, so as long as we're on this side of it, we can change our X position by 20 this way. If we aren't on this side of -450, then we're going to rotate the fish 180 degrees. So let's see that in action. We keep going left, left. Oh, and we hit 450 and now we've flipped upside down because we've done our 180 turn. This might be a good way for us to check for the different bounds so that we can't hit move left and move off the edge. I know one of our students downstairs was working on a little D-pad so that he had a left, right button, up and down, and was adding some of the logic to say, well, I'm not going to let you move left if you've hit the edge of the screen because I don't want anyone disappearing off the edge of the screen. Okay, so now we want to think about, well, okay, so I've got two fish on the screen here. I don't want them bumping into each other. I want this to be a pretty flat game. So I want when this fish hits the whale, I want something to happen. Maybe I'm not able to keep going forward. So the way I would do that in a game, there's often these utilities for doing this thing called hit testing to see if a certain point on your fish overlaps with a point on the whale. Now, this isn't a full-fledged game framework we're using. We've kind of rolled our own. We've taken some of the Camera Create code to build our own. So we're going to do a rudimentary version of hit testing. So I was kind of digging around and I was trying to figure out a nice, easy way for us to determine the distance between these two items. And I said, you know what? I bet, and more often than not, this happens when you're using Apple's frameworks. You say, you know what? I bet they've already written something for me that I can use. So what I did, and I'll just show you this. You don't have to go do this yourself. I went and looked at the source for this playground, which you can do by hitting these three dots. You go down to the advanced section because this is fairly advanced, and you say View Auxiliary Source Files. Now there's a few things in here like a license file, We have the edits, so anything that I've added goes in this edits folder, but this contents folder is where we're interested in. Now I know that just from experience that the code for this playground is in the modules folder. And we can see a few playground modules, and this is all the code for this book. Now I'm going to go look in SPC core, because that sounds like a likely one that it has some core code for this playground. I'll go look in sources. There's a playground folder supporting and extensions. I'm going to look in supporting. And I can see that I have these files. So an authorization manager.swift, point.swift, rect.swift, helper functions.swift, and others. When we're writing our code, even though we may not have seen it in a lot of our playgrounds, we're writing them in files called something.swift, which is the extension to let Xcode and Swift know that, hey, this is a Swift file. I should try to treat it as such. So if I tap on helper functions, then we saw this with the myCamera.swift. And then I tap on the screen anywhere for helper functions. I can see that, okay, cool. Well, we import foundation, import gameplay kit. Okay, well, that sounds cool. That's just adding code from those frameworks so that it's accessible in here. I have these things called public extension string. That's not what I'm not interested in. There's a constants. Okay. There's a comparable extension. There's a clamped integer array extensions. Okay. Interesting. And here I got here to the point extension, and I saw that there was this function called distance from, and you pass in a point and you get back a double. So what this means is they've defined a new method on the point type called distance, where I can pass in another point, and it'll figure out based on this math here. And this is why I didn't want to do this in the class. I didn't want to have to implement that with us live on air. That'll figure out, hey, how far are these 2 points from each other? So that does a bit of the hard work for us. So I said, oh, great, let's try that out. So I'm going to go up and hit the done button, and then I'll close out the source files. You'll notice I can't edit those, but if you drag this playground to a laptop, you'll be able to open it up and you can go edit any of these files to your heart's content. So I'm going to create a new function in here call it a function. We'll call it check for contact. And instead of spelling it wrong, we'll spell it right. All right, so check for contact. Now, it would be really nice if I made this function reusable. So what I'm going to do is I'm actually going to add some parameters. Let's add a parameter. So I want to check for contact between two different types, between two different components. So the first component we'll call first component, and we'll give it a type of component, because a component is basically anything we can place on the screen here. We're going to add another parameter, which will be the second one. Second component. And we'll use the colon over the K. And that's also going to be a type of component. So we're going to use that distance method basically to take these two, compare the first component's point to the second component's point, and figure out the distance between the two. So we're going to do let distance, because we'll store it in a variable, equal to. So first component, we need to get the point, because distance from is a method on points. So we're going to say position, because that'll give us a point. Actually, and you know what? We're gonna have to be a little less clever. So what we'll do is we'll compare distance between two. Let's use buttons in this case instead of components. Actually, here. Oh, that's not. Sorry, it's not public, so we won't use that. Maybe we'll make that public in the new version of this playground. All right, so we'll check for contact between two buttons anyway. So first component, second component, they'll both be buttons. Now, there's no autocomplete for this distance method in the helper function. So we're going to type it in as we saw from that helper file. And this is what it looks like, and I'll give you time to write this out yourself. So what we're doing is we're saying, okay, well, I know that that distance method is on a point. So my position property is of type point on my button. So I'm going to do first component dot position, and then I'm going to call this method distance, and then open parentheses from colon second component dot position, because that takes that from parameter is a point. So now if I pass in two buttons, say fish1 and fish2, what I'll get is I'll get the distance between those two. And what I want to do is I want to check to see. Now, to do this right, we should do the math. But for now, while we're just kind of setting this up, let's kind of roughly guesstimate. So let's see. Our sizes are roughly. So we're using the small size for fish 1. We're using no size for fish 2. So 40. So say if they're within 40 pixels of each other, we'll assume that they've hit. Okay, so what we'll do is we'll say if distance, and we're going to say if the distance is less than 40, or actually tell you what, we're going to do this. We're going to use less than or equal to 40. So this little equal sign at the end of our less than symbol says that, okay, before, if it was just less than, then distance has to be 39 or below. Now I'm saying that I'd also like to include 40 in there. So if the distance is 40, I'd also like to mark this as contact. Okay, so what do we want to do here though? Because we have to use this function to tell somebody, hey, if it's contacted or not. Well, we could use this in a condition, if check for contact is true, then we'll do something. Otherwise, we'll do something else. So the way we get information out of a function that we write is by adding what's called a return type. So if we tap on the braces here, we're going to get an option here. So we've been using the add parameter button. Now what we're going to do is hit the add return type, and we're going to see something new on our function. So you can see in here, I'm going to widen my screen so you can see it. So my function signature now looks like this. It says func, name of the function, so check for contact. These are the parameters. And then there's this, it looks like an arrow, right? There's a dash, and then there's a greater than symbol, and then there's a type. So I want to return a Boolean type. Now, when I call this function, instead of so if I call move left, it doesn't return anything. So I couldn't do something like let move left or let some variable name equal move left and then pass in a parameter, because nothing gets returned from in here. We just we run a bunch of code in here. In this case, what we're going to do is, so because we call this a return type, we want to return a value. So let's see. So we're saying that if the distance is less than or equal to 40, we're going to consider that contact was made. So what we'll do is we'll use the return autocomplete button there. And we're going to say return true. Okay, I have a little error here. This is saying that missing return in a function that expected to return bool. Well, I have one here, but guess what? If the distance is greater than 40, I don't return anything. So I need to make sure that I say return false. Otherwise. So my error goes away. Now, after all of this, after I've done all my moving around, I want to check for collisions underneath here where it says check for collisions. So I want to see if I collide with fish 2. So let's call our function that we just created. So check for contact. My first button is going to be fish 1. Second component is going to be fish 2. I should probably rename these parameters to first button and second button so that it's very clear that's what I'm getting. I'm going to store what gets returned in a variable. So I'm going to say let is hit is going to be the name of my variable. I'm going to delete that placeholder. So now what's going to happen is I'm going to get down here. I'm going to do my move, or I'm going to rotate. I'm going to say if we're going to say is hit is equal to the return value from check for contact. I'm going to pass in fish 1 and then pass in fish 2. So it's going to go up here. Fish 1 is my first component. Fish 2 is my second component. It's going to say, okay, so fish 1's position. Let's see if the distance from the second component's position. Let's figure that out and then store it in distance. And then if distance is less than or equal to 40, we're going to return true, saying, yep, we hit the whale. Otherwise, we're going to return false. So now that we have that value is hit, let's write a condition to do something, to test out our code. So let's use is hit as our condition. And if we're hit, what do we do? Let's see. Let's make fish 1 do something. Start typing in fish 1. Sometimes it's easier just to start typing so you narrow down your list of items in the autocomplete. Fish 1. What do we change? Will we change the... We could change the rotation, the scale, the size. Well, let's try this. Let's try the rotation, just because it'll be apparent what's going to happen there. So we'll set it to 90, so it takes a 90-degree turn. And that's it. So if this is hit, it comes back as true, the fish is going to rotate 90 degrees. So let's try it out. And you notice how our move left function has gotten a little bit bigger because we added this collision check. But we kept it in its own function, so it's a little bit cleaner because then we have all of our code in here. Instead of putting all this code inside our move left, now we can use this check for contact from other functions. Like I've only implemented move left. This is not a great game or an app because I'm only moving left. It'd be nice to have a move right, move up, move down. And in each one of those functions, I'd want to repeat the same kind of test. I'd want to check for contact if I have enemy ships or if I have other fish swimming around. All right, so let's run my code. We're going to expand the live view. I'm going to go left, left. Oh, so that came back as true. Check for contact, which is right because I ran into the whale's tail. I might want to change. Maybe it's got to be a little bit bigger than 40. And I turned 90 degrees. So this is one thing that you could add to your games now. This function right here, if you added a function like this check for contact or whatever you want to call it, you could call it hit test. You could then use this distance from colon second component position. So you need to pass in a point there. And remember, a position is a point with an X and Y coordinate. That helper function inside the Swift Playground that somebody else at Apple wrote, that'll do the math for you to figure out how far away you are from another item. So that's our check for contact one here. Let me leave that up there for a second. The last thing we're going to add, so if this is a game, and this is one of the lamest games you've probably ever seen, we also want to add a game over label at least. And we probably also want to add a score counter and lots of other things. But let's start with our game over label, right? So we want to draw a label on the screen. And in fact, I even have a note here saying show game over label. Okay, so if we're hit, I think we want to show the game over label. Again, this is not a great game, and everyone's going to get the same exact score. Not brilliant. So let's see. I can't add it down here because I need to define my function above this move left function for it to be able to be called from here. So let's select this comment. We're going to cut it. We're going to bring it up over here. So now let's create our game over label. Let's do that. So let's say func. So show game over. I don't need any parameters because I know I just want to show game over. I don't need a return type because it's going to do all the work itself inside this function. So I want to create a new component, a variable for components. So I'm going to say let game over label equal, and then I have, let's see, I have activity buttons that will go into tomorrow when we start talking about assemble your camera again. We have these decorate functions that are kind of cool, font name. We have this label type here. Let's pick that. Now it's a type, so I want to create an instance of that type, like so. That in and of itself is not very exciting. So now I want to style that game over label a little bit. Let's see, let's make the text, we're going to have it say game over. Okay, so that's not really styling it, that's actually giving it the label, the actual text to display. Let's go maybe add a text color. We can add a shadow color. We can add a shadow offset, which will draw the shadow a certain number of pixels away from the actual label. We can set a background color maybe so that it's more readable. Let's set it to, let's see, we'll set it to something dark, and then we'll set the color of the text to something bright. So game over label dot. We'll see that we have a property for textile. We can set up a textile type. Here's the initializer for our textile. We'll give it a font name. If I hit the dot over here, it'll give me a bunch of options for fonts. Let's see, let's just pick a random one. How about that one? Actually, I changed my mind. Let's change this to something like white. There we go. And then maybe we'll set a label or a border around it so we can see what's going on. So border color equals green, and then game over label, the border color, border width. Okay, so here's my show game over code. I haven't added it to the screen yet though, so let's do that. So let's say space dot add. And the really nice thing is that I'm doing this all inside this one show game over function, right? So it's all, anytime I have a problem with my game over display where it shows up, I know that I need to go back to my show game over function and tinker with that a little bit. So we're going to add the game over label. We're going to add it at the center of the screen, maybe a little bit above. So in the center, it's X is 0, Y is going to be, let's say we'll put it up above at 200. That's looking good. I still haven't called that function yet. So let's rotate the fish for game over. And then we'll call our show game over function. Scroll all the way to the end. Tap on that. Now let's run my code. This is going to be a very, very short game. So I'm going to hit left, left. Okay, cool. Not maybe the nicest game over. Maybe we can make it a little bit bigger. But not bad for a start. I mean, I have some feedback to the user. I could use this same label thing to add a score counter. So I know one cool thing, and this is the very last thing we'll do because I know we're running kind of long, is every time we move, maybe we'll add a counter here that we add to. Actually, do you know what? That's going to be a little bit more involved because we'll have to move things around. But tell you what, we'll come back tomorrow morning. The very last thing we'll do here, we'll leave a little note for ourselves, which is a handy thing to do if you're developing and you're like, oh man, I need to really go eat some dinner, or I need to go walk the dog or something. Leave a little comment for yourself so that you don't forget where you left off tomorrow when you pick up. So let's see. So let's leave a comment, say add a counter. And what that's going to do is that counter is going to, every time we move left, we're going to increment the counter. So we're going to add 1 to the counter. So it'll be a number, an int. And that'll be our score. So the number of moves you get to take will be your score. So what we'll do is we're going to draw a label tomorrow that says score, colon, and then whatever number you have. And we'll start out with 0. So that's what we'll do tomorrow, and then we'll get back to assemble your camera. On Friday, we'll be doing a look back session. And I hope your games are coming along really well. Feel free to post screenshots or videos online anywhere. Hashtag coding at home if you want. You can email them to us at live@thecodehub.ie. You can also post them in our forums, which are at thecodehub.ie/discussions. There are loads of ways to get in touch with us. We'd love to see the work you're doing. I know the 2 students I have in the house downstairs are doing an amazing job with their games. Feel free to send your stuff on. All right, so we'll see you tomorrow. We'll finish off our game and be able to keep score, and then we'll post some of this stuff in the actual Swift Playground that we have through our feed. So you'll be able to kind of tinker with this code in case you don't want to start from scratch and you want to have a little bit of a leg up. All right, we'll see you tomorrow. Thanks for coding with us.